Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the cross-site scripting module titled DOM XSS in document.write_sync using source location.search. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, select all labs, do a search on cross-site scripting labs, and go to lab number 3 titled DOM XSS in document.write_sync using source location.search. All right, let's get started. This lab contains a DOM-based cross-site scripting vulnerability in the search query tracking functionality. It uses the JavaScript document.write function, which writes data out to the page. The document.write function is called with the data from location.search, which you can control using the website URL. To solve this lab, perform a cross-site scripting attack that calls the alert function. Alright, so the target goal over here is to exploit the DOM-based XSS vulnerability and call the alert function. Okay, let's access the lab. Now notice over here, this is the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. When it comes to DOM-based XSS vulnerabilities, I don't really like using the proxy. Instead, what I do is I use the developer tools in the browser itself to understand exactly where my input is going. And so for today, we won't really be using the proxy. All right, the first thing that I do is map the application and see if any of the parameters could potentially be vulnerable to XSS. The way to do that is by putting in a string in the parameter and see if it's reflected back to the user or potentially even interacting with the document object model, or what we call in short, the DOM. So you could see over here we've got a search functionality. What I'm going to do is put in a unique string, so a random string. Let's say 1, 2, 3, 4, 5, 6, and click on search. Now you could see over here, it is reflected back to the user, and so this definitely needs to be tested for cross-site scripting vulnerabilities. And the way we're going to see if it's actually vulnerable is again by using the developer tools in the browser. So right click and then inspect, and then over here I'm going to do a Control F to search for my string. So 1, 2, 3, 4, 5, 6, and you could see we've got 2 matches for the string. The first one is the heading element, where it's reflected back to the user. This should be tested for reflected cross-site scripting. But then there's also another match on my string. So if we enter again, you could see that my string made it into this URL over here, which is interesting. So we've got resources/images/tracker.gif or GIF, whatever way you say it. And then we've got search terms is equal to the string that I put into this parameter right over here. So I'm wondering how this got generated, because if it got generated in an unsafe way, it could potentially be vulnerable to DOM-based XSS. So to do that, I'm just going to right click and view the page source to see if there's any JavaScript which generates this link right over here. So if we go right over here and search for search term, and here we go. So this is the JavaScript that is responsible for generating that URL. And if we just scroll to the right, you could see all it does is it takes the search parameter from the request itself, so whatever we put into this parameter right over here, and then it saves it in a variable called query. And if query is not empty, so if someone put in a string in that search parameter, it calls the function track search and gives it the string that we inputted in the search parameter. Now in track search over here, which is this function, it writes to the page using document.write saying create an image that has the source/resources/images/tracker.gif. Search terms is equal to the string that we put in the search parameter. Okay. So this could potentially be vulnerable to DOM-based XSS because, as you could see over here, this is client-supplied input it makes changes to the document object model. So it's making changes to the page and it's client supplied input. And so we should be able to break out of this string right over here and get the application to perform an action on our behalf. So let's copy this whole thing over here. So this is what it's doing. So it's creating this image tag right over here. And then you could see the image tag right over here. All right, so the idea is that when we put in 1, 2, 3, 4, 5, 6, as you saw over here, it replaced it in the query string and it became 1, 2, 3, 4, 5, 6. So what we want to do is break out of this image tag and then add our malicious cross-site scripting payload. So to do that, the first thing we need to add is a double quote so that we could close this double quote right over here. And then we need to close the tag for the image element. So we'll do that. And then we could enter any script tag that we want or any malicious XSS payload that we want. So in this case, the lab tells us that all we need to do is alert on something. And so we'll use the script tag to call the alert function. And that is it. So let's copy this. This over here would be our payload. You don't actually need to put in an integer because it'll just be empty. So we'll copy this, put it in here. And so now when I search, what should happen is it should create the image tag with an empty search term, but it also should create a script tag that automatically runs when the page is loaded that alerts on the number 1. So let's search over here. And here we go. We got alerted. Let's click OK. And you could see we get the message, congratulations, you solved the lab. All right, so if we go back right over here and we search for this string over here, so you could see the leftover double quote and the bigger than or equal sign that were left over from this image tag over here. You could see them on the page. So we're just going to search for them and see how we ended up performing our exploit. And here we go. So you could see over here, this is the image tag that takes in whatever string that is put in the search field right over here. We were able to close that string and then close the image tag and then add our own malicious JavaScript that alerted the user. And that's essentially it. All right, so we successfully completed the exercise by exploiting the DOM-based XSS vulnerability. In the next lab, we'll look at another case of a cross-site scripting vulnerability.